The next of our wonderful new assistant professors here at the University of Michigan is Liz Bondi-Kelly, and she's going to tell us about this stuff. You can do without the mask.
Yes, thank you. Yes, hi everyone. Thank you so much for the kind introduction and for the invitation to chat with you all today. I'm definitely excited to be here and share some of my work on realizing AI for social impact. So first of all, I believe that artificial intelligence, or AI, has lots of promise to improve lives around the world, especially through use-inspired research in domains such as public health, conservation, and education. I've sought to build partnerships with stakeholders in each of these domains, including through a nonprofit that I created called Try AI, devoted to increasing diversity and inclusion in the field of AI and exploring AI in society. I'd like to briefly emphasize my collaboration with Air Shepherd to try to mitigate illegal wildlife poaching. I built a simple user interface in which they are alerted, optionally with a sound, upon the detection of a human and an animal. And I'm not going to go into the details of this, but I wanted to bring this up as an example because this deployment of this simple user interface was the result of a multi-year collaboration with Air Shepherd, which involved many, many hours of discussions and screen sharing, including while Air Shepherd was in the field when possible. And so I found this to be vital for successful deployment. So in my experience from these collaborations, including this one with Air Shepherd, at least two common challenges arise when trying to realize AI for social impact. First, we may have limited, noisy data, which amplifies uncertainty. And I've worked on some algorithms to account for this, including in security games and bandits and data augmentation strategies for limited data. We also need to plan on involving humans in most cases. For example, during deployment, when we give someone our system to use, like we were just talking about with Air Shepherd. And in my work in building these AI systems for social impact, I seek to address these challenges throughout the process. Today, I especially aim to highlight how I've thought about responsible AI development and deployment of AI for social impact so far in my work. So in particular, I'll discuss how we can work with humans in the face of uncertainty, and I'll discuss having interdisciplinary inclusive teams during this development and deployment. Throughout, I'll also include a few references to these collaborations with conservation and public health nonprofits and emphasize Try AI at the end. So let's get started with an example. So to frame this discussion, let's start with the conservation domain, and in particular with a camera trap, shown here on the left. So images are captured by these camera traps when they detect motion, which can help scientists study animals, things like their behavior, their movement, and so on. But sometimes they can be falsely triggered. For example, if there's wind and it's moving the grass in this image. In this case, there truly is an animal, very difficult to see down in the bottom right. So because the camera trap can sometimes be falsely triggered, we may want to build an AI model to predict whether an animal is present or not. However, this can be tricky when we have uncertainty in our model. For example, if we have a low-quality image or a rare species. In selective prediction, when we have one of these uncertain images, we can ask a human what the contents are, which we call deferring to a human. And this can often increase our performance over either the AI model or the human individually. So we built our own simple dynamic programming selective prediction system for this study using the system predictions, ground truth data, and human labels. And the intuition is that this helps us find where it makes sense to defer to a human or to rely on the AI model itself. Most prior work on selective prediction, similar to what I was just talking about with building the model itself, assumes that if an AI model differs, then a human would just label it as though they were not influenced by that interaction. And so we can evaluate those systems with synthetic data sets or old human labels from when they observed the image initially. But recent work has shown that there are some impacts on human behavior when they interact with model predictions, for example. So what happens in a scenario where we really have a human in this selective prediction setting? I led a human participant experiment to try to answer this question. So participants were first trained briefly. We told them about camera traps and went through some examples with explanations, including this example that we just looked at earlier. Then we mentioned adding the AI model, as shown here. And it's followed by another few examples with the AI model predictions and explanations. And I want to just point out that we mentioned that deferral means that it's uncertain. So then, once we go to our deferred images, we varied the message showed to participants before they made the decision about animal presence. So you can see up here in the top left the messages that we used. There are 4 types. The first is no message. The second is a deferral message, where we're saying something like the AI model deferred, meaning that it's uncertain. Then we had a prediction message, which gives some information about the uncertain AI model prediction, or both. And then the participants can see the image, as we can here in the bottom left. They can then decide whether there's an animal present or not. In this case, we can see from the circle that I added for the presentation, not for the participants, that the AI model's prediction of no animal present is incorrect. So we invited about 200 participants on a crowdsourcing platform called Prolific, and we had them look at 80 of these deferred images, which were balanced in terms of whether the uncertain AI prediction was correct or not, and whether they contained an animal or not. There weren't any repeated images. We never told users that all of the images were actually deferred by our selective prediction model, and each image was randomly allocated to one of those message types. We did this random allocation 4 times with 50 participants in each version. So once the experiment was complete, we did end up finding statistically significant differences in accuracy simply by changing that message that people were looking at. So in particular, for this data set and for these participants, we see an improvement in accuracy for defer-only messages compared to no messages, which we think might be because it might serve as a cue to concentrate harder. And then we also see that predict-only is performing worse. So to better understand that decrease when we show a prediction, we calculated something called conformity, which is how much humans increase their agreement with the model when the prediction is present. So we found that humans do use the model prediction since the conformity is greater than 0, especially when they have low confidence when the conformity is higher. So humans use these model predictions, but why is it a decrease rather than an increase? So as shown by the decrease in predict-only incorrect compared to no message incorrect, we find that exposing humans to the incorrect predictions of the AI model makes them even more likely to be incorrect. And furthermore, on the right plot, we analyzed participant accuracy when there are no prediction messages. Participants are correct 66% of the time when the model correctly predicts animal or no animal, but only 50% of the time when the model predicts incorrectly. So participants and the model therefore tend to err on similar images. So because of this, we have to carefully present the AI model uncertainty and prediction to humans during deferral, for example, by only telling them that the AI model is uncertain. And if we do this, humans can help us overcome the AI model uncertainty. Similar principles arise in health. In health, there is often uncertainty, and increasingly AI models are being used for applications from clinical aids to patient-focused tools and beyond. We can even imagine similar human-AI collaboration modalities where perhaps an AI model will make a prediction and a human will review it. And similar trends may arise here too, namely that there can be this bias towards listening to what our AI model predicted. So in recent work, my co-authors and I sought to draw inspiration from aviation as we begin encountering some of these challenges during the deployment of health AI systems. And this is because of the advances in safety in aviation over the years. For example, there were 40 fatal accidents per 1 million aircraft departures in the United States in 1959, and this figure has fallen to around 0.1 per 1 million aircraft departures as of 2014. There are many lessons we can learn, including some cautionary tales. Aviation is great, but not perfect by any means. But one lesson that I'd really like to draw your attention to today is the extensive studying of automation bias in aviation, which is the tendency of humans to listen to what the model is predicting. So some strategies that aviation takes to reduce automation bias include pilots spending thousands of hours in aircraft simulators to learn to appropriately interact with automated systems. Another example, in the TSA, sometimes people will, the TSA will put examples, mistakes in the system and record whether the TSA officers listen to that or not. So now it's time to think more about interdisciplinary inclusive teams. So far, I've discussed health and conservation applications. Collaborations have been vital in each, especially when considering deployment, as hopefully we've seen so far. For example, this aviation project I was just alluding to, we had 12 interdisciplinary collaborators, from clinicians to lawyers to aerospace experts. But can something more be said for how to develop, deploy, and evaluate AI systems in general? So along with interdisciplinary co-authors from computer science and philosophy in this case, we worked together to propose a new framework to address these questions. Our goal was to define AI for good in a specific context in collaboration with the community most impacted by it. This goal is based on the capabilities approach, which prioritizes the ability of people to function as they wish. So we're thinking about how AI can impact that. Then, to understand the kinds of lives that individuals value, my team and I proposed to use a participatory approach to involve stakeholders in both the development and deployment and evaluation of the deployment. So as part of this, we proposed a set of guiding questions to try to help AI practitioners implement the framework. I've sampled 2 to briefly look at together. First, how are impacted communities identified? I've often started by trying to reach out to nonprofits, like we've talked about, and have sought to build long-term relationships with them and hopefully others who could be impacted by the AI system that we're developing. Second, it's important to determine what these stakeholders wish to achieve and measure, for example, capabilities when evaluating a system accordingly. And I hope that some of these questions and lessons learned, both from this and from the aviation domain, can guide researchers in developing and deploying AI systems for social impact in collaboration with communities. And another way I've sought to increase inclusion in building AI systems is through TryAI, the nonprofit organization that I've founded. Our goal with this work is to increase diversity and inclusion in the field of AI by supporting students in exploring AI in society. We're primarily working with high school and early undergraduate students, particularly those from historically underrepresented groups. So through all of the events that TryAI has done so far, we've served over 50 students, many from these historically underrepresented groups in computing and AI we're hoping to include. And in informal surveys after the event, all of the student respondents have reported an increase in interest in AI. I'm very excited to continue to improve these programs to create the most useful possible experience for students. So to reiterate, human-agent interaction is very important to consider while building and deploying AI systems, and can be used to overcome challenges like uncertainty if done strategically. There's also a need for interdisciplinary inclusive teams while developing AI systems for social impact. And by emphasizing these principles and others that we're hearing about today, I think, again, that AI has a great deal of potential for positive impact in the world. And I also believe that we must work together with people like domain experts, students, and those impacted by these systems to ensure that AI is truly an opportunity for humanity. So with that, I'd like to thank you so much for joining me today and to quickly thank my amazing collaborators. I'm happy to take any questions.
Okay, question back there.
You may have mentioned that I missed it, but can you talk about how you decided which images to give to the human versus AI? And second question, if I may, any thoughts on how FDA would perceive these approaches, collaboration between?
Yes, thank you for the great question. So I really briefly flew through this. Basically, we built a selective prediction model to help decide, as you said, whether the human should review it or if we should rely on the AI model. There's a lot of work looking at this. We used a very simple approach here, where we were basically trying to balance between what our AI model predicted and whether it's correct, and what were the historical human labels and whether they were correct, and then try to basically, you could imagine, deferring when we think the human will perform pretty well, but if we think the AI model will perform pretty well, go with what the AI model predicts in that case. Yeah, and then the second question, in terms of the health AI systems and how the FDA will react. That was one part of our analysis that I didn't allude to today because it can get a little bit complicated. But my understanding is that basically there are some modalities where the FDA would need to go through an approval process for looking at the AI or machine learning model that is proposed. But in other cases, maybe not. So for example, if you ask a doctor to make a decision right off the bat anyway, as they normally would, and then maybe you provide the option to look at an AI model response, then it might not necessarily have to go through review. But I want to defer to my colleagues who are experts and lawyers, like I mentioned, to really get into the details there. But thanks for the question.
Thank you for the talk. I think you mentioned how putting some of the images on deferred actually increases the accuracy in terms of the results. I wonder what your thought is on fully automated AI devices, such as fully automated driving. Would you say at the end it will be possible for just fully trust on AIs that will rather choose to predict over you instead of deferring to you to incorporate your thoughts?
Yeah, so great question. I think that it's important to consider lots of different potential modalities of human AI collaboration. My personal feeling is that when we are looking at some of these high-risk domains like driving, or in these cases like health or conservation, that it makes sense to involve our human stakeholders and human experts in the decision-making process. And so this deferral is one mechanism we can use to do that. But there are lots of others. Like I was alluding to earlier with the health systems, there might be a case where we want the human to make a decision first, and then the AI serves just as a decision aid. In this case, sometimes we are truly just trusting the AI model to make the decision. So I think it will vary very much depending on the model performance and the setting. Thanks.
Okay, well, thank you very much.
Thanks, everyone.